Okay, so we're in Module 2.5. Here's the warm-up. Again, as always, we'd like to pause and try these, see if we can identify these three-dimensional figures. Once you get them jotted down or what you think they're called, go ahead and unpause. So I'm going to scroll down. Here's what we have. Again, we've seen some of these terms probably in 7th and 8th grade math, not really very much of it in Algebra 1. But we have prisms, we have pyramids, and then prisms and pyramids are named based on the shape of their bases. And then you have cones, cylinders, and spheres that all kind of revolve around circular shapes. So in lesson 5, we're going to find surface area and volume of a variety of different three-dimensional shapes. These are something that I really don't expect you guys to memorize. So as we go to take this chapter test, along with some of our transformation rules and a couple other things maybe that I'll sneak onto there, what I will do is add these to a cheat sheet that we will be able to utilize. You should be able to identify the parts and the characteristics of them. Once you know what it is, just plug values in and find the surface area or volume. So first of all, again, you don't need to write all these terms down, but you should recognize them. So if you need to jot them down in your notes so that you can, by all means do. But if you can see the word a couple times, see it in the direction a couple times, and know what they're referring to, that's pretty sufficient for me. So a polyhedron is a closed three-dimensional figure made up of flat polygonal regions. A face of a polyhedron is a flat surface on the polyhedron. An edge is a line segment where the faces intersect. A vertex of the polyhedron is the intersection of edges. The bases of a prism or cylinder are the two parallel or congruent faces of the solid. The base of a pyramid or cone is the face of the solid opposite the vertex of the solid. So now they'll walk you through kind of understanding what the bases look like. So anytime you have a prism, all the sides that are not the bases are going to be either rectangular or square shaped, basically have some sort of four-sided shape to it. And then you'll have your two parallel sides, so you can clearly tell in this pentagonal prism that we only have two parallel sides. It's the top and the bottom. The rest of them would not be parallel. They would intersect at some point. So that's a pentagonal prism. And then on the right-hand side, you have a pyramid. Again, you could say that this is just, a triangular pyramid, a pentagonal pyramid. It just depends on what that base is. So because that base is just a four-sided base, you could say a rectangular pyramid. It just depends on what that shape is. You can see here the circular shapes. So again, the opposite sides that are parallel, the opposite faces that are parallel are still your bases. In the cylinder, the cone is the base that's opposite the vertex, and then obviously a sphere is just the set of all points that are equal from a radius. And so there's no faces, there's no vertices, there's none of that stuff for a sphere. Okay, so here's kind of some common ones that you'll see: triangular prism, rectangular, and pentagonal. And then you have triangular, rectangular, and pentagonal for pyramid. Those are some ones that are pretty commonly used in geometry. And we'll kind of find some formulas here that work for us to find surface area and volume. Right and oblique, again, we don't work a ton with oblique figures, so when we see those kind of slanted figures and slanted images, that's what it's referring to. In other words, your lateral sides instead of your bases aren't all right angles. They can be different angles. They can be slanted and things like that. It's still considered a prism. It's just an oblique instead of a right. And then we have here some regular polyhedrons. And again, these are some ones that are pretty commonly seen in stuff. Those of you that play board games, especially those ones that are kind of outside of the norm. You can see some of these octahedrons, dodecahedron, icehedron. These ones have multiple faces on them that are used in a variety of different things. The more common regular polyhedron that we see is a hexahedron. Anyone that's ever had like a dice in a game that they've used, that's a pretty common thing to see. And then a tetrahedron, again, all those triangles are exactly the same. So again, just like a regular polygon, a regular polyhedron, all the angles, all the sides are the same. So that's how those work. They don't work for every type of shape. It's just not possible. So these are some of the ones where it does work and the more common seen ones. So first things first, determine whether the solid is a polyhedron, identify the solid if it is. A polyhedron, name the bases, faces, edges, and vertices. We don't have to name all of them in every single problem. When we do a test or a quiz, I'll probably just say name the edge that's between these two planes, whatever the case may be. For the sake of this example, though, we'll go ahead and name them all just so that we can kind of see where they come from. So the solid is formed, or the solid blank formed by the polygonal faces. So blank, so it is a blank. There is no base, but the solid has blank equilateral faces. So it is a blank. So again, it is a polyhedron. It's formed by triangular triangles that are touching all at vertices. It's not a regular polygon, but it is a polygon because the triangles probably aren't all the same exact size, and because we have that square that's kind of taking up the middle where they meet. So the square on the inside isn't technically a face of the polygon, but it is showing us that we basically have two pyramids stacked on each other. Bases that doesn't have any. So the bases are kind of meeting in the middle. And so we have two vertices. The faces, remember, are planes. So when we go to name the faces of a polygon, we're going to call them planes. So plane, let's say STQ would be this kind of front left, and then SRQ, and then plane QRU, and plane TUQ. Now, there are four more. I'll just read them off, but I'm going to list them all out because I'll take up the whole thing. So the other four are plane SRV, TVU, and RUTV, and then SRV. I think I got them all. I might have said them twice. RUV, UTV, TSV, SRV. So just going around the four-sided base that's kind of stuck in the middle there. The edges, again, are segments. So when we list the edges of a polygon, so like SQ is an edge, it's a segment. SR is an edge. RU is an edge. UT is an edge. QT, QU. There's a lot, right? There's a lot of edges here. Now, again, I'm not going to have you list out all of them because it takes a long time. Vertices isn't as bad. There's only 6 of them, so the opposing vertices are Q and V. Those are points. And then you have S, T, U, and R. So S, T, U, and R. Note here, though, notation of plane, notation of segment, notation of point. So the faces are planes, segments, points. Have to have the correct notation. Again, this is not a polygon, so technically it's not it's not one of our normal platonic solids, but it is still considered a shape. So types of solids, this is one of our cylinders that we saw up above. So again, the solid has a curved surface, so it is not a polyhedron. It has two congruent and parallel circle bases, so it is a cylinder. Again, we're going to have some pictures in our practice set where it just says identify as best as we can. Now, obviously, this has curves to it. This is one of those old school like coffee thermos things before they, got all cool and people spent $1 billion on them. This is what they looked like. But we can recognize what polyhedron or what shape they're trying to do there. Okay. Same thing here. So again, if we kind of ignore the base being a different shape, if we look at kind of the very basic, go ahead and answer and check in the practice notes for the answer, but kind of just focus on that part of the polyhedron. Okay. This is something, and again, you can pause this. This will be on a cheat sheet for you, though, when we go to take a quiz or a test. Go ahead and pause this, but for the sake of time, I'm not going to leave it on here for a real long time. But you'll see the ones that have a circular shape to them or circles to do with them. You'll see pi r squared or pi r cubed, depending on whether it's volume or area. Ones that have, the regular shapes, square, rectangle, triangle, you'll see kind of pieces of those things in them. So these are shortcuts. Obviously, on ones that are not circular, there's always just, you can add up all of the faces of the polyhedron to find the surface area, and then volume, you kind of do need the formula for volume. So just keep that in mind when you're doing those. Now, one thing I will draw your attention to before you guys pause is everything that is a capital letter stands for something more than one dimension. So for instance, the P in that is talking about the perimeter of your base. So whatever you call your base in that rectangular prism, you need to figure out the perimeter of that shape. Same thing is this B is talking about the area of that base. So anytime you see a capital letter in your formula, you need to make note that that is not just a single dimension. That is probably a perimeter or an area of something that you would call the base. And they do a good job down here of really drawing attention to that. Okay, so find the measurements of the three-dimensional figures, find the surface area and volume. So if I want the surface area of a cone, we have that formula right there. Surface area is equal to pi RL plus pi r squared. Excuse me. And then volume is equal to 1/3 pi r squared times height. So really all we need to find the surface area is the lateral height, and then so we need to find the slant height of this, and then we need to use the radius. So I know the radius in this is 15, so pi times, we'll say the radius is 15, and then I need to find that lateral height, so I'm going to leave that blank for just a second, and then pi times 15 squared. Surface area is easier because it just wants the height, so I'm going to go ahead and work that out really quick. So pi 1/3 pi times 15 squared times my height is 8. So because I already have that dimension, I'm going to go ahead and work that one out real quick. So 15 squared equals, and then I need to take that times 8 times pi and then divide by 3. So times 8 equals, and then divide by 3 equals, and then times 3.14. So 1884 approximately. I feel like that rounded off a lot. Maybe it's exact. I don't know. I feel like that shouldn't be exact. So approximately 1884 inches, and that's volume, so that should be cubed. Okay, so now when we do this one, I have an issue of, I don't know what that slant height is. I know this is not 18, but this is 15, and this is 8. But if we know anything about right triangles, we should know that we can find that. So I can say the Pythagorean theorem should tell me what my missing slant height is by doing 8 squared plus 15 squared. So 8 squared plus 15 squared. And then if I take the square root of that, so second square root of 289, I believe that's a perfect square. 17, yep, perfect. So that's the number I need right there. So now I can do 15 and 17 multiplied together. 15 times 17 equals 255. 255 pi plus 15 squared, I believe, was 225 225 pi. And you can actually add those together and then multiply. So plus 255 equals. So 480 pi is a perfectly acceptable answer. So we're going to say clear. 480 though times 3.14 equals 1507.2. So approximately 1507.2, and that's in inches squared because that's surface area. Okay, so again, lots of just plugging in and calculating. Most of this is stuff we've seen before. The cone, cylinder, and sphere are actually easier because, as you notice, there's no capital letters in the formula. So make sure before you do this check and go check your answer that you need to call one of these faces of this rectangular prism your base. I can't remember for certain, but I want to say that I called this face right here the base. So when you go to find the capital P and the capital B in your formula, I'm talking about the perimeter of this base and the area of this base in that formula. So before you go check your answer, double check that. Again, I might not have, I can't remember for certain, but I want to say that I did. So that's a 10 by 6 rectangle on the front and the back. Okay. Calculate the measurement by using three-dimensional models. The New Year's Eve ball is a geodesic sphere that is 12 feet in diameter and it weighs about 11,875 pounds. It is lit by 32,256 LED lights and is covered with 2688 crystal triangles. How many lights are contained on the ball surface within an area of 4 square feet? If you see one like this on a test, it would not be something that I would ask you to do. For the sake of time on this video, what I want you to understand, I have it worked out in your practice set, but you're going to find the area of the whole thing, and then you're going to divide it down into just one. It says how many lights are contained on the ball's surface within an area of 4 square feet. So I think you're focusing in on just one of these triangles for the LED lights because it says all of the LED lights are here. So understand it's a very involved question. I don't want to take up way more time than we need to in this video. I want to get to this one that we can cut up and do down below. So when we're doing this one, this is one of these prism problems where we're kind of cutting stuff up and cutting it out. But keep in mind, we can figure out the different dimensions of the pool. Now, again, for the sake of time, odds are what's going to happen is we're going to see one or two of these in the practice set. But these take up a ton of time. So I like these as kind of skill development problems and practice problems. But if we're taking a quiz or a test, I really don't want us getting stuck on something like this. So this is kind of one of those depth of understanding problems that if we do see something like this and you can do something a little bit deeper, this is bonus type problem here. And odds are it will be something where if you can get to it and get it done, awesome. If you can't, that's okay too. But again, there's no volume formula for this figure. So what we have to do is pay attention to what this shape is right here and then cut it into some stuff that I can find the volume of. So I can find the volume of this. I can find the volume of like this, but you have to cut out the volume of that triangle right here. And then I can find the volume of this, and then we can just multiply it by how wide the pool is. So it's not an impossible problem, but just very time consuming. Essentially what you're doing is you're taking a bunch of these rectangular prisms and cutting them up. Okay, so go ahead and take a second. I scrolled too far there. Try to do the exit ticket. The problems in the practice set, like I said, they're kind of asking you to identify figures, tie figures to real life objects, and then just find the surface area and volume of some basic prisms and pyramids, cones, spheres, cylinders, things like that. You will obviously have time to work on it this week. We'll have time to ask questions. So don't stress too much if you don't get it all done today in class. Do your best, work hard, make sure you're doing things the right way. Thanks, guys.